Welcome back, students. It was observed that some of the properties of glucose and some other monosaccharides is not explained by its open chain structure. Just like it was observed that glucose exists in two alpha and beta crystalline form, and this was not observed on the basis of open chain structure. So for this, it was suggested that there is another type of structure possible for monosaccharides, and that is known as cyclic structure of monosaccharides. We are going to study about this cyclic structure of monosaccharides and especially glucose in this video. So let's start. Actually, there are some reactions of glucose which are not explained by its open chain structure. Just like pentacetate of glucose does not react with hydroxylamine, but actually it must react with hydroxylamine as there is a free aldehyde group. But it does not react with hydroxylamine. This indicates that the free CHO group is not present actually in glucose. So, and similarly, glucose exists in two crystalline forms, alpha and beta. Alpha form crystallizes from a concentrated solution of glucose at 303 Kelvin, while the beta form crystallizes from a hot and saturated aqueous solution at 371 Kelvin. So these two observations indicate that there are some properties which are actually not explained by open chain structure of glucose, and that is why it was suggested that glucose exists in two cyclic forms which exist in equilibrium with the open chain structure. Let's have a look at them, that what are those. We know that the structure of that glucose is like this. Yes, the structure is this. This is the aldehyde group, then an OH here, then an OH here, OH, CH, 2 OH. This is alpha D, actually not alpha now, it is actually D-glucose. D-glucose. This is open chain structure of D-glucose. But it was suggested that what happens, there are 6 carbons, 1, 2, 3, 4, 5, 6. So this OH actually comes here and reacts with this carbon to form a compound like this, in which carbon here, then OH, then H, and an OH group at this side, then at this side, another at this side, then oxygen comes from here to form this compound. This is suggested to be alpha, actually this is beta D-glucose. Beta D-glucose. This is a cyclic form of glucose. Similarly, there is another structure possible for this cyclic form of glucose, and in this H would come on this side, OH will go on that side, and this will result in formation of this compound, this OH, then OH here, one OH here, and a structure like this. This was told to be alpha D-glucose. So there are two actually cyclic structure of glucose. One is alpha form, another is beta form, and they both exist in equilibrium with the open chain structure. And these two differ from one another by this carbon only. In this one, OH is present on right hand side, in this one OH is present on left hand side, and these two are anomers. Alpha and beta form of a compound are anomers, and this carbon is anomeric carbon. Okay, so this can also be written in another way, another projection, and that would be like this. If we want to write the cyclic form of this, we'll write it in this way. let's say this is carbon number 1, this is 2, this is 3, this is 4, this is 5 and this is 6. So this is carbon number 1. At this point, OH, all those groups which are on this side, right hand side, would be written in the bottom. So at this position, this OH, and at this position we'll get this OH, then at this position it would be this OH group, and then this position we'll get CH2OH group. This is actually pyranose form, and the name of this structure would be alpha D glucopyranose. Similarly, this can be written in this form. Here would be OH, then one OH here, then one OH here, then one OH here, and this would be CH2OH. This is beta, this is alpha D glucopyranose. And this was beta D glucopyranose. So these are pyranose forms of glucose. Similarly, there is cyclic structure of fructose also. The structure of fructose is like this. Here comes a carbon, CH2OH group here. There is a carbonyl carbon, then an OH, one OH here, another OH, and then CH2OH. So what happens that this OH goes with this and results in formation of a cyclic structure CH2OH. Then OH comes here, OH, OH, and CH2OH. This is actually alpha fructose, alpha D fructose, in which the OH group is on right hand side. Another structure possible is like this: COH on this side, CH2OH on this side, and one OH. This is beta D fructose. Alpha D fructose and beta D fructose, two anomeric forms, and the structure for this would be like this. Carbon number 1, 2, 3, 4. So CH2OH here, then OH here, on this OH on this side, then OH, then CH2OH. This is alpha D glucopyranose, alpha D fructofuranose. This is called furanose form because its structure is similar to furan, and that in case of glucose it was pyranose form. And for this, if we want to write it, it would be like this: CH2OH on this side, here would be OH, then an OH here, OH, CH2OH and H. So this is beta D glucofuranose. So these were the cyclic structure of glucose and fructose. These are the structure fructose. These are the cyclic structure of fructose. These are the cyclic structures of fructose. Next is mutarotation. Actually, what happens then when alpha D glucose is dissolved in water, its specific rotation is found to be in starting plus 112 degree, But with passage of time, this specific rotation of solution decreases, ultimately reaches to a value of 52.5 degree and becomes constant there. That means whenever glucose is dissolved in water, after passage of time, its specific rotation keeps on decreasing and then it becomes constant at a particular value. Similarly, when beta D glucose is dissolved in water, initially it has specific rotation of 19 degree, plus 19 degree, and this increases with time and again it becomes constant at 52.5 degree, and this phenomena of change in optical rotation is known as mutarotation. And this happens because whenever glucose is dissolved in water, its chain opens and then recoils in opposite direction, because of which its optical rotation decreases and increases in case of beta D glucose. Now there is a solved example. The change of optical rotation of glucose solution with time is referred as, yes, it is mutarotation. We have just discussed about this. Next is methyl D glucose and methyl alpha D glucose and methyl beta D glucose are. So we know that alpha and beta are, if we are talking about alpha and beta form of a particular compound, that means we are talking about anomers. Alpha and beta forms are known as anomers. So students, we studied about cyclic structure of glucose and also fructose, and we also know that what are anomers and what is mutarotation. In our next video, we will study about disaccharides. Keep watching. Thank you.